good evening, good afternoon, I guess. I'm Liz. I am not from Louisiana and Mississippi. If you can tell by my accent, I'm a native New Yorker. I've been down in the area running the Chalmette Refinery for 2 years now. So just if I don't make sense, just let me know if I'm talking some northern terms on y'all. So an overview of cane sugar refining for those that don't know. Basically the raw sugar comes in on a ship, we store it in our warehouses, we transport it from the warehouses up into the refinery via belts and bucket elevators. It goes through minglers, the affination step, we melt it, phosphatation or carbonation, basically our clarification step, and I'm going to talk about the two of them a little bit. Filtration, decolorization, evaporation. Then there's some storage tanks in there. Then crystallization, mixers, centrifugals, dryers. Then it goes on to our silos and storage. And there's also a recovery process. So that's a really quick version. I'm going to talk about a couple of the key parts of the process and how raw sugar quality affects them. But to start off, what matters to a cane sugar refiner, right? So safety, quality, sustainability. Good safety, right? A safe plant is a well-operating plant. As most of you probably know, Pete Mariah, he used to preach that to all of us. Correct quality products. So what we put out the door to our customers, we want to make sure it meets all of their specs. Minimal sugar losses, right? So that's physical, chemical, the molasses purities being too high, all different versions of sugar losses. Consistent and reliable operation. That's something that's key, something that we focus on, particularly in Chalmette in the last 2 years, is being more reliable. A plant that runs steady state runs much better. Energy, sugar losses, everything come into play. With that, minimal energy and water use, right? So there's a big effort within ASR to drive down what we call our 100 squared, so our water and energy use across all of our refineries. Manning levels. So make sure we have the right people in the right jobs with the right skill set. Environmental performance, making sure we're meeting all of our Title V permits and all of our bulk chemical storage permits. And then product performance, making sure we're making our customers happy. So to do all of that, what matters from a raw sugar perspective, right? So some of the parameters and where they affect. Grain size and particle size distribution. That really has a significant impact on conveying the raw sugar, that makes sure it flows, so we have it in these big piles up in the raw sugar warehouses. Does it flow down? Some of our refineries have what we call holes in the bottom of the warehouses up in our Yonkers and Baltimore refineries, and it has to flow down onto belts. In Chalmette, we're payloading it, putting it onto a big hopper, and again, if it doesn't flow onto the belts, it poses challenges for the refineries. Percent moisture. That also impacts when it's sitting in the warehouse, right? So one of our coworkers who's chief science officer helped me with this paper. So he talks about some avalanche angles and all sorts of ways you can calculate how to store raw sugar in the warehouse. But I'll just say if it's too wet, right, it's not going to make some nice piles. We can't pack as much sugar in the raw sugar sheds we want to, and then we can't take as much raw sugar in as Lorenzo over there would like me to. So moisture is important. And also if it sits in the warehouse, it'll degrade if the moisture, if it gets wet. Pole, right? So the pole, the percent sucrose, that affects how much refining we have to do. So people know about VHP, right? Chalmette traditionally is not processed VHP. We could potentially bypass an affination step if it was very high pole. Most of the time it's not. But that pole also determines, right, how much affination comes off the sugar and then how much further we're going to have to handle it in the recovery process. Color. So different refineries, I'm going to show you, have different decolorization processes that are used. And depending on the color of the raw, determines which or how many of those processes we have to utilize to get the end product that we want. Total suspended solids, particularly sand, bagasilio, that affects our filtration processes. And then polysaccharides, right, starch and dextrans, that affects the viscosity once the melt streams are going through, and it affects the filtration processes, especially in carbonation. And the last thing is ash. Sorry about that spelling. It influences the amount of de-ashing capability required, right? So particularly in recovery, right? So if there's a lot of ash, it's harder to recover the sucrose crystals. And in a refinery that uses ion exchange or de-ashing beds, it can obviously put a stress on them if the ash is too high in the raw sugar. So just a block diagram, right? So raw sugar comes in, it's an affination process. Then the clarification. Chalmette is a carbonation plant. The plant I came from originally is a phosphatation plant, so just two different types of carb. Decolorization, either ion exchange, granular activated carbon, or char, which is what Chalmette has. Sorry, brain fart there. And then crystallization and centrifugals, and then finally refined sugar, and then an offset of that is the recovery house. So to go a little further into detail, right, affination, melting. The primary decolorization is our either carb or phosphatation, right? So that's, as I mentioned, different plants use different types. Filtration, which can be press filters, deep bed filters. Again, depending on, I'm going to show you towards the end, there's a way to kind of set up a refinery if, depending on which unit operation you have, determines the next one you have to have. You also kind of design it around the types of raw sugars you think you're most often going to get. Decolorization, again, the different types. Evaporation, crystallization. Most of our refineries do between a 3 and a 4 boiling. A 5th boiling usually becomes a soft sugar boiling or light brown sugar. Drying, conditioning, and then bagging and packing. So just to start off, right, raw sugar. So it's important we bring in barges, vessels in some of our refinery, right? So safe port operations, just docking and undocking vessels can be challenging at times, especially in weather. Storage and the conveying of raw sugar is critical. We want to make sure that there's stable piles, right? So we have people in our warehouses, in payloaders, and just people walking around at times. We want to make sure those piles are good. They're not going to collapse on people, and that's why some of the parameters are important. No color or heat development, right? So if it's too moist or we're not storing it the right way, we can create color just in the shed alone. And then dust, right? Sugar refineries have learned in the last, I've been in the business 27 years now, I would say in the last 10 years, right, there's been a significant change in the raw sugar. There was a lot more inherent moisture. It wasn't as dusty. The raw sugar now does have a lot more dust, maybe less inherent moisture. And it's something that we've had to take into account the way we store and convey the raw sugar. We actually have dust collection systems in some areas. We have different monitoring systems to make sure we're not overheating bearings. So the Baltimore refinery a couple years ago had a significant fire due to the raw sugar. So we've had to change the way we think of raw sugar as a product, let's call it, and treat it more like we treat our finished granulated sugar. Raw sugar is basically conveyed via elevators, belts, screws, or scrolls from the storage area up into the wash house, which is our first process in the refinery. So affination, magma is fed to a centrifugal where the crystals and syrup are separated, right? So you take raw sugar, for those that know, and you take the affination, which is the molasses left on the crystal that you spin off. You remix it, you mingle it together, it causes that molasses to loosen on the front of the crystal, and then you're able to spin that affination off in that first step of the centrifugals. In that process, you also use water. You determine, based on color, you vary your water and your drying time. And that's, based on what's coming in, it's a balance of you want the lightest color coming out, but you also don't want to make too much affination and stress the recovery side of the plant. So you're balancing your drying time and your waters, and when you hit it on the centrifugals to get the best raw sugar liquor coming off and going through refinery and not overtaxing your recovery side of the plant, which I'll talk about in a couple of minutes. Okay, so the basic process, this is basically how Chalmette is set up, right? Carb, filtration, and then decolorization. So affination and recovery melters. Then it goes to carb, where we add milk of lime and CO2. In Chalmette, we use the flue gas off of our boilers. That's carbonatated liquor. That goes to your primary filtration. In Chalmette, it's press filters, where you add compressed air and steam, basically to operate those filters. And then that pressed liquor, that clean liquor, goes on to decolorization, which again in Chalmette at this time is char. In other plants, for example in Yonkers, excuse me, it would be phosphatation, press filtration, GAC, and then ion exchange. So again, different ways that refineries can be set up. Off that primary filtration, it's we call a mud, right? It's a sludge, so it's the calcium carbonate that comes off, gets pressed out, and that goes back through a sludge press to get the sugars out of it, and that water comes off and goes to sweet water. I know I'm going through this kind of quickly, so I apologize, but I'm going through these processes so that you can see the overall, and then I'm going to explain how the parameters in raw sugar affect these processes. So in the carbonation process, it does two things, right? It decolorizes, and it's a filter material. It makes a filter material, excuse me. So it decolorizes by trapping color molecules, and then it makes a filter material by adding the CO2. It's going to make that calcium carbonate that then gets taken out by the presses. So each step in the process, right, how it operates affects the next step in the process. The better and the more uniform the crystals that we grow in carbonation, the better the press floor will operate. If you have all different size crystals, some of them can bleed through, some of them blind up the filter cloths, and then you can't get the liquor through. But they also need to be a little bit rigid, right, so they can withstand the pressure of the flow going across them. So carbonation decolorizes by trapping crystals, but you also make the filter media, which you want to be as uniform as you can for the next step in the process. So starch, right? This is the beginning where we're going to talk about where the raw sugar kind of affects the refining process, right? So I'm not going to give everyone a science lesson, right? But starches can be a part of the raw sugar. They are chains. They can be small. They can be really large. They can be soluble or insoluble. Soluble starch is not good because it obviously it dissolves, right? And then when you're trying to form your crystals in the carbonation step, it causes challenges in having uniform crystals, which again affects the next step or the press stage. Insoluble starch can be just as challenging because it can gel up on your presses. It can also even cause a gel-like surface on your centrifugals in the wash station. So both forms of starch are challenging. Different refineries, depending on what processes they have, could handle different ppms of starch. Starch, particularly in Chalmette, can be challenging, right? Because it affects carb and it affects the press floor if you have soluble and insoluble. In Yonkers with the phosphatation, you can handle a little more starches because you can take it out with the mud of the phosphatation clarification step. But it also can't handle an unlimited amount of starch. So just some examples of where Chalmette starch and filterability has been. So January of 21, just comparing January and November. So the graph on the left was the total starches, right? And January to November, it's came down significantly 30%. But what you see is the soluble starches went up, the insoluble starches went down. And at that time in Chalmette, they had a really challenging time running through their press floor, right? Carbonation was okay, but the press floor had a big challenge with that. So carbonation, right? As I mentioned, it removes color. It also makes the filter media. The quality of the raw sugar causes you to make changes in your milk of lime, the CO2, to control the pH. So there's different parameters that we can change that are a direct, effect of the raw sugar qualities. I'm not going to go through all these slides. I kind of talked about the key points earlier. So this is a graph of in Chalmette running the carbonation process, right? So that middle, you can see where the raw sugar color went up, right? So feed color, I'm talking about the raw sugar color, it went up significantly, right? But as you can see, the red graph, which is the product color or the carb liquor color, it stayed relatively consistent. Had a slight uptick, but not horrible. So that's an example where you can take a higher color raw and make changes, milk of lime, pH, what you do in the wash station with the water and the drying time, and you can allow the plant to run at a steady state. But if that blue line were to go up significantly, there's only so many changes we can make. So decolorizing and deashing. So decolorization, basically, as I mentioned, depending on what type of raw sugar you're going to bring in, whether it's a VHP or even the origin of the raw sugar, will determine what process you want to use for decolorization. As I mentioned, Chalmette has char at this time. Whether we're going to go to ion exchange or something else in the near future is still to be seen. Other plants, like, as I mentioned, I compare to Yonkers because that's where all my experience is, right? In Yonkers, we had granular activated carbon and then ion exchange. It made sense because Yonkers was set up to handle Florida raws and make a lot of liquid sucrose. Chalmette is set up to handle Louisiana raws and make a lot of granulated sugar. So depending on what you have coming in and what you have going out determines how you set up a refinery. As I mentioned, if you have VHP, sometimes you can bypass affination. But you have to be careful because depending on if you're bypassing affination, you're also not washing off some of the ash. So again, a balancing factor. De-ashing, it depends on what the product is. If you're making a lot of liquid sugar, you might need de-ashing step. It also would be required if you are not crystallizing the sugar and then melting it to make liquid sugar. In Chalmette, that's how we make liquid sugar, so we have to watch the ash content. In other plants, we have ion exchange, so we have a de-ashing process. So again, I'm not going to go through this whole graph, or table, excuse me. What this is showing is the different combinations, right? I mentioned carbonation, phosphatation, activated carbon, ion exchange. So some work together better than others. And this is a table that just kind of shows that different combinations, right? That one is a preferred, for example, carb is a preferred for ion exchange. Other ones don't work as well together. So it's just a table, I think, that for years have been used to determine the best way to set up a refinery if you are building one brand new. So evaporation and crystallization, right? In evaporation, it's important to avoid foaming. So if you have a lot of dextrans or you have other solubles that get through and you don't get those out in the press station or in your the carbonation station and they get into the pan floor, particularly on the recovery side, they can cause foaming, right? Foaming's a problem from an environmental perspective. You foam over, you're putting it into the Mississippi River, which you don't want to do. Crystallization, you basically typically evaporate our pans on, we grow crystals under vacuum. So you're constantly increasing the concentration while you're evaporating off the water. And again, that's where it becomes really important to make sure that you're not going to cause foam. Skip through some slides because there's a lot of data in there, right? Sucrose recovery. So as I mentioned early on, depending on the pull of the raw sugar, there's a balance of how much you can wash the impurities out versus handling it, so you have a good liquor stream versus handling it in recovery. So sucrose recovery, the boiling is affected by impurities, right? So recovery is probably where the raw sugar, besides the initial color, on recovery end, if it's high color raws, if it's got a lot of impurities, whether it's ash, color, moisture that we have to wash out, all of that's going to recovery. And that means that many more strikes you have to handle. All refineries are set up with limited capacity. So eventually what happens if you have to put too much to recovery, you're going to end up putting out high molasses purities, which is going to affect your sugar loss from a refinery. So as I said, it's a balance, right? You want the right liquor stream, but you don't want to overtax your recovery stream. This is just a material balance around recovery boiling. Most of our refineries are set up with 3 strikes, so a high, a middle, and a low. You start off with high, with your affination, which is your highest purity stream coming from your wash station. And then you're adding streams and adding sweet waters along the way for a middle. And then the low purity, some people call it a C, is where you eventually make your blackstrap molasses, and that goes out as a byproduct of the refinery. So in summary, right, a number of raw sugar impurities contribute to the complexity of refining those raws, as I mentioned. Colors, moistures, ash, starches, and dextrans. The ranges from the impact of those impurities range from the raw sugar surface properties, meaning in the wash station, meaning on carbonation, meaning in the press floor and how we handle them, all the way through to the recovery house. So higher dextrans can also affect the recovery house. So we set up that we have parameters that we can play with in order to cope with the different range of raw sugar impurities. The other option is to buy VHP raw, and then you can bypass affination. You can have a steady state raw sugar coming at you, and you can set your refinery up one way and just run. That's not how most of the dominant sugar refineries are set up. We're set up so that we can move around based on the raw sugars that we see. And that's it. And it was very quick. So any questions? So pull out and refined sugar is basically, 9 to 9, right? So pull in,
No, say tons. You're gonna, any industrial process, you're gonna lose some things somewhere.
right.
Total recovery in
So
material.
most of the refineries are set up, I think this maybe answers your question well, is like a 1.06 to 1.07, right? It takes 1.06 pounds of raw sugar to make 1 pound of finished product. Probably best way to answer that. Yes?
Miss Shack, you were right. I don't understand your accent.
I'll work on that. Yes.
Briefly, white sugar, light brown, dark brown. All of the same refineries?
So they're all made in the same refinery, yes. White sugar is early in the process, right? So it's right after decolorization. Light brown and dark brown are actually made on the recovery process. We use molasses in them, but most refineries are all boiled, just different feed streams.
Can you talk a little bit about your new golden sugar from Domino and that it was the consumers asked for this? And do you make it in Chalmette?
No, unfortunately, we do not make it in Chalmette. I'll start with that. We make it down in our Okeelanta plant in Florida. So basically, what we do in that is we're leaving more of the affination, more of the natural molasses on the crystal. Not quite the same as a soft sugar, but so we kind of process it less and leave the feed streams darker. And then when we spin it, we purposely don't wash it up as much to be as white. So that's why it's considered a little less processed than granulated sugar. And yes, consumers, right, the thought was consumers like natural, organic, tan and brown is good, right? So that's where the golden sugar came from. Yeah. Yes?
Some of the mills make VHP sugar. Does that help the refinery out?
Yes, it does. We can generally bypass the whole affination step.
Would you all consider a premium in that if that process continues?
I'm going to look at Lorenzo to answer that one over there, but I would say yes, probably.
One little question. So y'all do receive some international sugar. Do y'all notice the difference in the refinery's operation running domestic compared to running import on raw?
Yes, it depends on where it comes from, right? So I will say in Chalmette, in my whole 2 years down here, we've only seen, I think, one Mexican cargo come in, right? It's mostly Louisiana and Texas. So I can't down here, but in Yonkers, we see a lot of variety of raws. And yes, the correct answer is it depends on where it's coming from. There's a ton of variety, a Dominican versus a Mexican versus a African cargo. They're all very different. So a lot of variety, yes.
In your process right now, do you, so some of the sugar you're getting is very hard boiled and some that you're not, do you separate that any kind of way so that you can run without affirmation for a while?
We do store the raw sugar in piles that we know this is Louisiana, this is maybe from a certain mill or a VHP. Yes. So we'll do it for two reasons. Either for what you said, where we can try to run without the affination step for a while, or we do it so we can blend the cargoes and make basically a raw sugar out of a blend that's best for the refinery to run. So we do it for two reasons.